Oh, dang it. No. Already there.
Alright. Can I just leave this here?
Look at the video now.
Can I just leave this here and like jump onto the whole video?
Okay, can you erase my board, please?
Just completely ignore. Thanks for breaking it.
That wasn't me.
Oh, erase this side. So, limits. We're gonna get the notes out. We're gonna talk about limits. So Abraham, you're gonna be my cameraman.
Hey.
Weird like that.
That board too?
Yeah.
People like on the video just be like, it's just Ibrahim washing a board.
Let's live stream the seesaw part.
No, you should make an intro video. You know, like with a really loud, like bass boosted music.
Hey guys, it's your boy, Yay!
That works.
Can we actually? Who's good at video editing here?
I don't know.
Anybody good at video editing?
Is that supposed to be you?
No, I'm good at other things that aren't that.
I don't think I'm not that.
Yeah, like robotics or math.
I don't know that one.
I don't know about that one.
Is this water? Bro, every time we come here, you have like a half-filled water bottle. Can you just?
Ah, my arm.
Why do you open it if you're not gonna drink it?
He likes to stay hydrated.
This is not hydrated. I drink more water than this in a day.
Well, you don't know
In a
if
day.
there's another water bottle before that.
Oh yeah, I'm dehydrated.
Alright, so we're gonna start by talking about the first
Is
question.
it already recording?
Yeah.
Yeah.
Hey guys, it's your boy.
What did you say? This is a Bridget.
Stop recording me.
We're zooming in, sorry.
Yo, I'm gonna cry.
Hi, bro.
Bridget, we're done.
This part. Okay, so we're gonna start by this question. What is f of x is equal to x cubed minus 1 over x minus 1? And we say we're gonna find what happened when x is equal to 1. Okay. What happened when x is equal to 1?
Vertical line.
Vertical line, yes, but it's like you're missing something. It's maybe it's not even correct, but it's maybe a vertical asymptote. It's maybe a vertical asymptote, but it's not entirely the asymptote. Can you record the whole screen? Is the whole screen recording?
Mm-hmm. Yeah, the
The
whole board.
board?
Well, not that.
No, this side. This side.
Yeah, that one.
Okay. So now we're gonna look at it. We say, okay, we can plug in a value. We're gonna plug in a value because if we plug in f of 1, what will happen? I'm gonna get 1 to the third minus 1 over 1 minus 3. Well, 1 minus 1, that's equal to 0 over 0. Okay? So 0 over 0 in terms of math is no longer undefined. Okay? In the past, you might think it's undefined, but I never told you that was undefined. I always told you that's undetermined. Okay? It's undetermined is because we don't know what that value is. Okay? So what we're gonna do is we're gonna turn on the projector. We're gonna try. Somebody tall enough to turn. Ben, you probably.
I got it. I got it.
I got it.
I got it.
Sit down. Or
Why do I have a picture that it goes over? Okay, so what we're gonna do is we're gonna use decimals. We can use driving calculator too. So those of you guys have driving calculator, take it out and learn how to use it as well.
See, I didn't know if you were saying. No, like first you just go, I was like, She's like, this class is crazy.
So get your graphing calculator out.
How's the screen?
Maybe you ate it on accident.
I need my calculator.
Yes.
Okay, so if you look at the function, so we're gonna show you two different ways to do it. So we're gonna using Desmos
That's just not sensible.
and
That's just.
That's not, that's what
Wait, it's right there.
where
In the middle, yeah. Or the other one. There's many. Whoa.
did I show you this yesterday?
No.
No.
Yesterday was
Yeah,
such
I
a.
was here yesterday. We all skipped.
So we're gonna type in this function. Make sure you have parentheses, especially when you type in calculator. So minus 1 over x minus 1. Okay, so you see this graph, there was no vertical asymptote, right? There was no vertical asymptote like what do you assume? Like when the bottom equal to 0, you usually have vertical asymptote, like what Bridget says. But in this case, there's no Bridget, there's no vertical asymptote. But what happened at 1? That's the thing, what happened at 1? So what we're gonna do is you can use table value, so you can use that on the thing. So we're gonna edit this, and then you're gonna type in convert this to table. And obviously 1 they told you is undefined, right? So on your graphing calculator, you're gonna type in y equal to,
Where's the Y?
It's the alpha and then the 1.
okay, so y
It's
equal
the
to,
green one.
Okay.
Alpha 1.
okay, and you're gonna type in a function with a
Where's equal
parentheses.
though?
So what you're gonna do is you're gonna type in parentheses of x cubed minus 1 and over x minus 1 parentheses. So you need to have parentheses top and bottom. So you need to type in the parentheses on the bottom as well before anything. So you need to make sure you have those two parentheses things. Otherwise your calculator is not gonna come out correctly. Now if you do this, okay,
Yeah.
then you click graph, then you should graph, and you should come up with this problem. Okay, those of you guys are graphing calculator.
Oh, yes, finally.
Okay, so you click the graph, it should come out. Now, what's the nice thing is this, I think the calculator is very helpful, but however, I like to use Desmos because Desmos is more illustrative, much easier. So let's just say we don't know what a 1 is, so we're gonna say, hey, that's we do projection mode, so let's say 1 is, we don't know what 1 is. 1 is undefined. So we're gonna do something that's so close to it. So pick a value that's close to 1.
0.99.
0.99, okay, let's start with like 0.9, is that okay?
Yeah.
Okay, so let's go with 0.9. So what we're gonna do, we're gonna erase all this value. We're gonna say 0.9, and we're gonna get a y value is 2.71. Do you see that? And then what we're gonna do is we're gonna do 0. What's a value that's closer to 1 but is 0.9? That's pick another 9, right? And let's say 0.999. Okay? Obviously we cannot use 1. So what we're gonna do is we're gonna do it to the other end as well. We're gonna do 0.99999. And we're gonna keep on doing it until we're getting closer and closer. Do you see that? And then we're gonna do it from the other side as well. So let's say 1.1, right? 1.01, 1.001, 1.0001, 1.00001, right? Do you see that value is going to what? If we reach 1, what is that value supposed to be? 3. So that means the limit, as I'm approaching to there, because I cannot plug in 1 in there. If I plug in 1 there, yes, you're gonna get indeterminate. But if you plug in some value that's closer to it, then you can figure out what the value is approaching to. Now, if I get rid of this chart, right? If I get rid of all this chart, I don't know if I can get rid of all this chart at the same time, probably not. So what I'm gonna do is I'm gonna copy the same function. Go to here, type in the same function. And we're gonna highlight this function here. What happened is we got all of the value here that's closer to it, but when we get to this 1, that is going to be an open circle. That it says 1 is undefined. But what happened is we get so close to it. Remember I give you the black hole analogy. Like black hole is right in the center here. And then we say, hey, we want a ridge. So Abraham's come to me. Yeah, we're gonna go look for black holes, right? So Abraham's gonna be a future scientist. Go back up. Getting too close and make me feel uncomfortable. Maybe a body slam. Okay, so what happened? We see this black hole. So what we're gonna do is we're gonna take one step closer, take in our GPS and take one step closer. Yeah, and then we both reach at the same time. And we cannot get into the black hole. If we get in, we both suck in, right? But we can get close to it, and close enough where we can say, hey, this probably this black hole is this location at maybe 1/3. Does that make sense? Okay, thank you. Okay, so this is called a limit process. The limit process is take a value that is closer and closer and closer and closer and closer until you get to that point. You say, okay, that is almost like this, but you have to reach from both ends. There are sometimes you only need one end, but in this case, preferably from both sides. Keep on getting closer, 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 get to one point. Okay. On your graphing calculator, how would you do that? Well, what your graphing calculator, you're gonna go to, those of you guys have graphing calculator or don't, it's okay. So we're gonna show you graphing calculator. So, Ladybug. And if you don't have a graphing calculator, what you're gonna do is you're gonna get one of mine here.
I should get to one. What? I don't know. I think that
And you just have to find a
doesn't even let me.
battery, which is I don't know.
No, click the button trace if you want to stay online.
Yeah, but it doesn't even get to one.
Yeah, it doesn't let me either. It goes to like 1 point.
Well, I guess we're one.
1.06.
Bro,
Yeah.
you wanna turn off the light?
1.02.
Turn off the light, we better. Is
Yeah.
that better?
You can't see it.
But turn on like the
Like,
ladybug.
There's a button for focus.
Wait, okay.
There.
Oh my god, the focus is so good.
It's so bad.
Microscope skills.
Okay, so
It's
Use that course and find
zoom in.
all of mine.
Wait.
Okay,
Oh, yeah, there you
there
go.
we go. That's better.
Okay, so what we're gonna do is we're gonna type in the function says y equal to. And see that on top? Can you see that? And you do a parenthesis x to the
Here.
I see.
q minus 1 parenthesis divided by x minus 1. Are we okay here?
Yes.
Okay. So what we're gonna do is we're gonna click graphing, and you're gonna see that graph. That graph. No, we're not seeing the graph.
Yes.
Why is that?
Good.
Why is it not seeing the graph? Okay. So now what we're gonna do is you're gonna click on the top. It says table set. Second table set. Second window. And the table says table starting value. The table starting value is going to be 0. And you don't want to do 0, 1. You're going to do, sorry, I'm going to go back to the table set here. And you're going to do input independent. I'm going to put ask. Okay, change the independent to ask. Why you change your independent to ask? Because I can plug in any value. So what we're going to do is the second table again, well, second graph. It's going to give you a value, and it's going to give you a table right here. And you're going to plug in 1.0, 0.9,
Graph.
and that should get you 2.71. Okay, 0.99, that should give you 2.9701. And 0.999, that should give you 2.997. Do you see that? The ask, so you gotta do the plug in the ask, they will come up with value. You can do it in terms of table too, but the table set you can change to auto, but I don't prefer auto, I prefer ask because I can ask any value I wanted to. So you can ask 1. When you ask 1, guess what that's gonna be? Error. So you don't wanna do 1. Okay, so how many guys need graphing calculator? Okay, how many guys will buy one? Will buy one? You already have one? And you?
No, I have one.
You don't have one? Who else? 2,
I have one.
3, 4, 5.
I don't have one, but I'm gonna.
I have one actually.
You got your one?
I'm gonna.
I mean, this one, if you want it, I can sell them.
How much?
But how much?
80.
Oh,
That's
bro.
not bad. That's not bad. Wait, but most of them are like 100 something. That's not pretty good.
That's
Yeah,
$80.
it's
The original was
Like,
136.
So that's not pretty good.
Yeah.
But this is a nice color too.
I'll buy it. I'll buy it. I'm calling this.
Yeah.
Wait, I thought you had one already. Oh, you don't have
I
one.
raised my hand. You just couldn't see me. I was on your right side.
Okay, but you can. Okay, question about this part. So you can build a table and try to plug in each individual values and see what happens. Are we okay here? Okay, so what we're gonna do is you're gonna try on decimals. If you cannot do it on a graphing calculator, you're gonna do it on decimals. You're gonna do it to this equation, and this equation is gonna be what? Limits. Let me write down here. Limits as x approach to 0, x over square root of x plus 1 minus 1. So you're gonna close to 0 and see how far you can get there, and you see what happened. What is the value? Because you type in 0, it should not come out. So when limit x approaches 0, that means what happened with 0? What I'm gonna get? 0 over square root of 1 minus 1, right? That's equal to 0 over 0. It's undefined or indeterminate? It's indeterminate, right? So 0 over 0 is indeterminate. Okay, so you can turn on the light. No, the light. Okay. So you're gonna build a table, right? You're gonna build an x, y, and then we wanna do, let's say, which value you wanna go with? 0. Which 0.1 and 0.01 and 0.001, and we don't know what happened to 0. So what's on the other side of the value? 0.999? No, that's not it. Negative 0.001, right? And that's 0.01, and then 0.1. So if you build a table and plug in those values, you're gonna find out what 0 eventually go into. Does this make sense? So what does 0 eventually goes to?
2.
It's going to 2. So what happens 0.1? 2.04? 88? And then what's this one?
0.005.
And 2 point what?
0005.
Okay, and we don't know what this value is. And what happens if you negative 0.001?
1.9995.
If you see those both ends is exactly the same difference, it's like, do you see it's 0.00005? And this one is probably what, 1.995?
Yeah.
Right? And then probably, which one's 0.1 is
1.9487.
94? 87? So you see that's going to what? 2. So limit that can approach to 2. Question about this part. Does that make sense? So you can do limit process. So first thing about limit process to plug in the value, but the plug in the value gets 0 over 0, that means there's some weird things gonna happen over there. It's a black hole, technically. We cannot reach there because when we reach there, it's like a hole. But inside in here is a white hole, not a black hole. So, questions? Okay, so, but this question could change. Okay, it could change. So different times where different things can happen. So, now we're gonna look at this one. And we're gonna talk about all this question again, algebraically. Okay, we're gonna talk about all this question again, algebraically. So, this is the question I care about, is limit as x approaches 0, and the absolute value of x over x. So a lot of you guys cannot see the picture of this. If you don't graph it, you probably don't see it. But if you graph it, you're like, whoa, that's a completely new graph that you never envisioned yourself to see. So absolute value of x over x is something that is weird. Okay, absolute value of x over x. Okay, let me turn off the projector. I need my VR stick.
Yep.
Watch off the projector.
Yeah, turn off.
I'll let you get it this time. Alright.
You had to press a bit longer to turn off.
I wish there was like a search
Where
button.
did you pick up
Yeah.
And probably I didn't.
Let go and press it again.
Just
Press
click
it,
it
press
once.
it again.
Mr. Yeah.
Yeah? Alright.
Is there an absolute value button?
There is an absolute value button. Okay, it's second catalog, second 0, and then first thing's ABS.
Oh.
There is a catalog. Amazing. Thank you.
Yeah.
I looked at the limit.
Okay,
Gosh,
So,
this was a longer question.
second
Oh,
is-
this was like-
catalog, second 0, so which is catalog, and the second 0 is going to give you.
Yeah, I enter.
Oh, I thought we were on this.
Oh.
So if you graph it, you come out something that kind of out of expectation, right? Because we never learned this kind of graph. We never learned this kind of graph. What does the graph look like?
2 straight lines.
2 straight lines, right? And one is going from this way on,
So weird.
and the other way is going this way from this way on. You're like, well, that's interesting. But what happens if I do limit x approach 0 in this case?
You won't have one because like. from
It's
the
coming
side-
down to a, one is going to positive 1 and one is going to negative 1, right?
Yeah.
So this is where that limit does not exist. Remember Mean Girl? Watching Mean Girl movie? Limit does not exist. I don't know. I never watched that movie. I just hear it.
Sure.
I watched that secretly.
Probably watch it every weekend, bro.
Any question about this part? So therefore, when they reach from the positive direction, so if I were to say limit x reach from the 0 from the positive side. From the positive means I'm going from the right side of this function. And then this value of, we're gonna say is absolute value x over x, that eventually is gonna go to what? Just 1, right? Does that make sense? Because they go into positive value 1. Now what happened was limit x approach to 0 from the left side of absolute value x over x, that's equal to what? Negative 1. Therefore, limits x approach to 0 for the absolute value of x does not exist. So if they reach 2 different things, that does not exist. If they reach one value, that exists. That value which they reach at doesn't exist. Are we okay here?
Yeah.
So let's talk about definition of limits. Definition of limits says limit x approach to a from the left side of f of x. has to equal to limit x approach to a from the positive side of x. If they reach exactly the same number that exists, if they reach, so if you have limit x approach to a from the left side of f of x does not equal limit x approach to a from the positive side of f of x, that means limit does not exist. If they reach each other, limit exists. If they reach a different number, that does not exist. I have questions here. Okay. We're going to talk about other things. Other things might be a little bit different. Now, what other time limit does not exist though? Okay, so limit does not exist happen in one thing. They reach both in a different value, or something like oscillation. Oscillation is like when you reach a value, it's shaking so bad, like violently. Okay, violently. So we're gonna talk about that situation. That situation is very weird. It's built by another function. Limit the sine 1 over x.
Guess who's out?
Who's that?
Me.
Yes.
This is my last day.
That's worth a celebration.
Caught up on the stream forever.
X approaches to 0. Okay? So this is a case that we say limit x approaches 0, sine of 1 over x. What we're going to do is to type in a couple values. So we're going to pick a couple values. So it's 1 over x. So we're going to pick x and y. So the value I'm going to pick is which interesting. I'm going to pick something that it says 2 over pi, 2 over 3 pi, 2 over 5 pi, 2 over 7 pi, 2 over 9 pi, 2 over 11 pi. So we're going to pick 2 over, I think 2 over, just 2 over 2 pi, and 2 over 3 pi, and then 2 over 4 pi, and 2 over 5 pi, and then 2 over what? 2 over what? 6 pi, okay. And then 2 over 7 pi, and then 2 over 8 pi. But if you do this, do it correctly, right? So that means 1 over pi, right? Because sine of, let's say, sine of 1 over 2 pi, right? So that means is equal to sine of pi. Does that make sense? Sine of pi is equal to what? Is what?
0.
0. Okay. What is sine of this? 1 over 2 over 3 pi. So that means 3 pi over 2. What is 3 pi over 2? Is what? Negative 1, right? Am I going too fast? Because this one is equal to sine of 3 pi over 2. And that's negative 1, right? What happened? But what does this value go into though? Is 2 over 5 pi, 2 over 6 pi, 2 over 7 pi, 2 over 8 pi? What does the value essentially go into? If I keep on continuous, go into what? The bottom's getting bigger, and the top stays the same, right? So the bottom gets bigger, the top stays the same. The top stays the same, bottom gets bigger. What's that value equivalent to? Just think about it. 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 6, and get to more extent. 1 over 10, 1 over 100, 1 over 1,000, 1 over 10,000. What's the value eventually go into what?
0.
0. Right? Eventually it's gonna go 0. So if I keep on doing this, what you're gonna find out here is gonna be what? Sine of 2 over 4 pi is what? pi over 2, what is sine of pi over 2? Huh? 1. Right? What is sine of 5 pi over 2?
5 over 2, so 1.
What is it?
1.
1.
Are you sure?
Yeah.
5 pi over 2?
Yeah.
Well, this should be 0, I think. Oh, pi over 2? No. This one is going to be 2 over pi over 2. This is a 1, right?
Yeah.
And there's a 0 here, right? 5 pi over 2.
Is 5 over 2.
5 pi over 2 is what?
It's 5 over 2.
Which is what?
1.
1?
Yeah.
Are you sure?
Not anymore, no.
So let's work it out, right? I don't know. What is it? Sine
It's
of
1. It's 1.
what? 5 pi over 2
It's 1.
is gonna be 5 pi over 2 is 1. Okay. What is sine of 3 pi? What is sine of 3 pi? 0. What is sine of 7 pi over 2?
0. -1.
Negative 1? Does that make sense?
Yeah.
Okay. Sine of 4 pi. 0, right?
Uh-huh.
So it turns out it's oscillating between 2.
Mm-hmm.
Okay? So what we're gonna do is you're gonna help me turn on the decimals again, and we're gonna erase this board. So we're gonna find out this value, but what we're gonna do is we're gonna look on decimals.
You want to do this and I'll erase the 1?
No, yeah, you erase board. We'll do that. This yes?
Yeah, it is.
Yeah.
The 2 over 4 pi one should be 0.
Yeah.
2 over 4 pi. Okay, I just did. That's why I thought you. Okay, so let's erase that part.
Everything?
Yeah, let's erase everything in the middle, so we're gonna show you on the screen. So, I have a very good analogy of this. So, sine over 1 over x. No, there's a difference. Sine of 1 over x. Did you turn on the projector yet? Good? No, you gotta break that thing. Come on.
I got it.
He's like lightly.
Okay, so sine of 1 over x, when they reach 0, something happened weird. So we talked about limit doesn't exist when they reach both different sides, right? What else? When it's oscillation. Okay? So we're going to look at a graph of this one, and we're going to see how do they really work. And you did now? Okay, if you see the value, when it goes to 0, I'm oscillating between 1, 0, and -1. And it's oscillating so fast, if you're in here, in the center, let's see what the value they get into.
It looks like a 5.
It's actually, we don't know, because it's oscillating so fast. Okay? So it's like here. We're gonna use Abraham. I'm coming back there. It's like this. So I'm gonna show you. Come here. It's like I'm slapping so fast.
I knew it.
Right? I slap it so fast. Like, and then 1 second I say, which side did I slap you on?
Yes.
You're like, I don't know which side, because I'm moving so fast, right? I'm moving so amazing fast, like super has oscillation. Oscillation is caused by that 1 over x value. So 1 over x, once it gets bigger, that's getting close to 0. But sine, so it can give you all different type of value. So I'm gonna give him like basically really fast slap.
Do it.
See, you're scared, you're flinch.
Because I don't want to get hit. Who wants to get hit, bro?
So does this make sense? Okay, so limit does not exist in this point.
I fixed it.
Because we don't know whether it's left side or right side. He doesn't know which side I slapped him on because he was slapping so fast. Does this make sense? So those 2 times does not happen. Limit does not exist in which location? When they left does not equal to right. Also, when the second time is, what second thing limit does not exist? When they're oscillating so fast, then that limit does not exist. Usually you don't see this case on AP exam. But regardless, we should prepare you for all the things.
Your
Yes.
big head is in the way of the graph.
So this is the part I'm slapping, right? Slapping right side, left side, right side, left side, right side. And so as soon as I go in 0, I'm going faster. So to this point, I really don't know which side I'm slapping at. Does this make sense?
Wait, I got the question.
Yes.
So it's because of the values that cause the oscillation?
Yeah, because 1 over x is when I'm going getting smaller.
Uh-huh.
Because it's look at 2 over 5 pi, 2 over 6 pi, 2 over 7 pi, 2 over 8 pi. The value is getting smaller. But when I'm getting smaller, I'm oscillating to 1 and negative 1, 1 and negative 1. But you cannot tell from the graph. The graph is going to be like bouncing so fast. I'm going smaller, but it's bouncing faster when I go towards 0. When I go towards 0, then that means I don't know which side it is. So limit in this case does not exist. So limit x approaches 0 at sine the 1 over x. This, when it reaches 0, it does not exist due to oscillation. It's oscillating so fast that does not exist. Yes?
So it's because for me it's like, you know how when we're finding limits we just get close and close.
On both ends, yeah.
So like with oscillation, wouldn't you just find like the two things that were like the closest to
No, because when they reach going closer, it's going to be like this. And you not really know which, it's 1 or negative 1 or 0. You just don't know. And once you get into a 0, it's getting faster.
Oh, okay.
So you're not knowing either whether 0 or negative 1 or positive 1. It's actually any value in between. It's actually any value in between. Okay? Question about this part. So limit, definition of limits, left, right, they have to reach a set point. If they reach different point, that means limit does not exist. If they reach oscillation, limit also doesn't exist as well. Okay? So we're going to talk about one other value here. What happens when limit of x approaches 0 at 1 over x versus limit x approaches 0 at 1 over x squared? So a lot of time when you have this case, it's probably easy. How many times light again? It's probably easier to graph it. If you graph it, you know what's going on, right? So what happens when limit 1 over x graph? Do you guys know what 1 over x graph is? It's like this, right? It's like my gang sign. You're not allowed to gang.
Wait. Keep it like
It's like this.
yeah, gang.
Yeah, gang. Gang of math. We do math for fun. We don't kill people.
We don't do math. We don't do math. We do math.
Yeah.
Just as bad.
Probably worse. So the graph is going to be like this. What happened when they reach 0?
They just don't.
Yeah, it one's going down, one. So when limit as x approach to 0 from the positive of 1 over x, that value is going to what?
It's
Going up.
positive infinity.
But it's going to positive infinity. Does that make sense? What happened when limit x approach to 0 from the left side? From the left side, it's going to what?
Like negative infinity.
So therefore, limit x approach to 0 is what? If you reach from both ends, do they come out same value? No. 1 over x does not exist. Now, what's 1 over x graph? Before you graph it, think about what's 1 over x squared graph do. If you guys don't know what is 1 over x, so I'm going to place that 1 over x graph. So x and 1 over x, right? So I'm going to do 1 over 10. That's gonna be what? If I plug in 1 over 10 here, it's gonna be what? 10, right? If I plug in 1 over 100, it's gonna be what?
100.
Good. And then the values keep on going up, right? Or negative 1 over 1,000, it's gonna be negative 1,000, right? And negative 1 over 100 is gonna be negative 100. And 1 over 10 is gonna be negative 10. So when they reach 0 is what? Does not exist, right? Because they reach once negative 1,000, once positive 1,000.
Negative 1 over 100 is gonna be equal
It's
to
all gonna be
negative
positive.
100. The
You forgot the sign.
Yeah. you
I forgot a sign.
Yeah.
Okay. Does it make sense? But what about 1 over x squared graph? But we know 1 over x is this. But we know what's 1 over x squared graph.
This.
Is it like
It's all positive.
It's all positive because this part is gonna switch, right? This part is gonna be completely switched. Actually, it gets much bigger, much faster. You're missing the slapping part?
No, she was here for that.
So when they reach the 0, so this part is actually like this. It's like a volcano. Okay? They both going up like this. 1 over x squared is a volcano. Okay, so the graph's gonna be like this and like this. Whenever x approach to 0 from the positive side of f of x, it's going to what? Positive infinity. Good. Or 1 over x squared. Sorry. And what happens when limit x approaches 0 from the left side? Positive infinity. Okay. Now here's a tricky part though. Now the AP exam on this kind of style question, the two answers will not coexist. Will not coexist. So what it probably I will put says limit approaching to 0 of 1 over x squared. This one I'm gonna say positive infinity. But sometimes people says does not exist. Because they don't believe in infinity, so they usually but either one answer are not gonna coexist on multiple choice. Not gonna be on multiple choice. Because they don't have, but if you pick one of them on multiple choice, you're fine, but they both answers not gonna show up at the same time. So either we pick positive infinity or positive pick it does not exist. Because we say that we don't know the value, so we don't say positive infinity. But usually I put positive infinity. If it's on FRQ, I put positive infinity. Okay, because this is kind of, they're still debating. Like calculus people still debating whether or not. I mean, a lot of calculus, there was a guy, I forgot his name, but he's a professor in, used to be a professor in Stanford, and then now he's teaching at Yale, and he's a really good professor. He's doing the whole argument against calculus now. He's saying infinity does not exist. Okay, infinity is not a concept should be approached when we're teaching calculus. So he's changing the whole view of things, and he has his own argument around it. So that's why we don't say is there infinity or does not exist. We kind of say it's kind of in between. In a case like this, it's kind of in between. So what's the basic thing with limits? The basic thing with limit is just plug in the value. But usually you plug in the value, so we're going to talk about this. So limit. The first step is to plug in a value. If you get a value, which is a rational number, let's say 3 over 5, then your answer is done. Okay, your answer is 3 over 5. But if you get a value, you're done. Okay, we're gonna talk about this tomorrow. Is that my bill?
No.
Yeah?
There's ours.
Yeah.
Alright, you gotta say bye to your viewers.
Bye, subscribe me.
You can do your gang sign now.
A gang sign.
Yeah, gang.
Yeah, gang. Do math, not math.
Honestly, it just sounded like you said do math, not math.
What?
Alright. Let's click the egg.